Today here we are going to have a chain rule. So let me summarize what I gave you last time. Last time here is I gave you so-called Bauer rules. What is Bauer rules? Bauer rules, right? Let me review what is Bauer rules here before I give you the chain rule. Okay, Bauer rules, if you have a bracket, that is whatever inside the bracket, it's a bracket to the power n. And now I need to take the derivative of this bracket to the power n. The rules here is that is your exponent, a bracket to the power n. I put n in front. Here is your bracket. I leave it as it is, n minus 1. And I have to multiply by the derivative whatever inside the bracket. The derivative whatever inside the bracket. That is called Bauer rule here. Maybe I give you one example here to just kind of review for what we have here. So maybe I solve this one here, b, 2b, or maybe I solve something different from what I solve in the class. So let me just take one of these problem here. I think we are able to solve. Maybe I go to number 12 here, just apply Bauer rules, right? So how to apply Bauer rules? Maybe I go for D. What is Bauer rules here? D here is just try to get this one here. So if I have, maybe I solve this one, D here. So how to solve D, guys, here using Bauer rules? D, if you have y equal 1 over x squared plus 4x, right? So here, this one here, you can solve it by using quotient rule because it's a fraction. What did you have here? 1 divided by. When you see divided by, when you hear divided by means it's a quotient rule. So, but some people, they don't like to apply quotient rule. Then what they are going to do here, you have to recall. You have to recall here. What you have to recall here, just try to, if I give room to myself. All right, so recall here, if you have 1 over a to the power n, this one here, it will be a to the power negative n. So this one, the exponent n, when I take it up, take opposite sign, which is negative n. So this one here, that is your a here, look what you have, that is my a here, a to the power what? It's a bracket to the power 1, a bracket to the power 1. If I take that up, you have x squared plus 4x to the power what? Negative 1. X squared plus 4x to the power what? Negative 1. Now I simplify. You have a bracket raised to the power, so which means I have to use Bauer rules. What is Bauer rules? Y prime, that is your n. Your n. So if you have f to the power n bracket, it will be n, f n minus 1, f multiplied by the derivative inside the bracket. So what is my n? Negative 1. What is inside the bracket? That is your f. What is your f? Your f here is whatever inside the bracket, whatever inside the bracket. So here is the rule, negative 1, and the bracket, which is x squared plus 4x to the power minus 1, n minus 1, n minus 1, n minus 1 like this. But do not forget to multiply the whole thing by the derivative, whatever inside the bracket, which is 4x prime. 4x prime. So if I simplify this, negative 1, that's a negative sign, right? Negative sign means, and the bracket here, x squared plus 4x. Negative 1 with negative 1, you get negative 2. What is the derivative of x squared? You have 2x. What is the derivative of 4? You just have 4. So that is, you don't need to simplify, just leave it like this. That is our derivative. If some people say, can I use quotient rule? Yes, you can use quotient rule, and absolutely it will be correct, right? Maybe I give another example here for this one here. I solve e here, down here. So what do you have? You have y equal 1 over x squared plus 4x to the power 5, right? So here again, you could apply quotient rule because 1 divided by a bracket to the power 5. But also this bracket, I can grab that, take it up. That is exponent 5. If I take the whole bracket up, it will be x squared plus 4x to the power what? To the power negative 5. When I take 5, positive 5 up, you become negative 5. Take the opposite sign, right? So now it will be easy because your n is 1, negative 5. Your n is negative 5. And here is your bracket, which is x squared plus 4x. you have n minus 1. What is n minus 1? Your n negative 5 minus 1. And I have to multiply by the derivative whatever inside the bracket. The derivative whatever inside the bracket. So you have x squared plus 4x to the power what? Negative 6. And what is the derivative of this x squared? You have 2x. What is the derivative of 4x? The derivative of 4x is just 4. X squared 2x. The derivative of 4x is 4, right? All right. So now I have to solve maybe another one. Maybe I solve h here. What is your h here? I'm just recall the Bauer rule before I give you a chain rule. So what is h here? H, you have y equal x to the power 4 plus x squared 1 minus 2x to the power 10 to the power 10. So what do you have? You have a bracket. You have a bracket to the power n. A bracket, you don't care whatever inside the bracket is okay. So you have a bracket to the power n. So now I need to apply the rule, which is y prime. It will be n. Here is your bracket. Just copy the bracket as it is. X to the power 4, x squared, 1 minus 2x, n minus 1. N minus 1. That is your n is 10 minus 1. And I have to multiply the whole thing by the derivative whatever inside the bracket. The derivative whatever inside the bracket. Right? The derivative whatever inside the bracket. So if I simplify this, you get 10 x to the power 4 plus x squared 1 minus, just simplify, x plus 4 x squared 1 minus 2x to the power 9. 10 minus 1, 9. I have to take the derivative of this, right? How to take the derivative of this? Just read it aloud a little bit. Hear yourself. Oh, x to the power 4 plus x squared divided by, when you see divided by means you have to apply quotient rule. What is quotient rule? If you have f over g prime, it will be g squared g f prime minus f g prime. Right? So here I have to do this separate here and then I go back here. So I need to get the derivative. So what is the derivative? X to the power 4 plus x squared. Right? Or you just, if you want to do it in one step, is okay too. But it's okay to do it separate and then go back here and just copy whatever it is here. So here is the rule. It will be 1 minus 2x. So the fraction here, 1 minus 2x, is that is your g. That is g here. And whatever you have up here, that is your f. Right? So here is the rule. I'm just apply the rule. It will be 1 minus 2x squared. And then 1 minus 2x. That is your g. F prime, which is x to the power 4 plus x squared prime minus. Then you have to copy. It will be f multiplied by g prime. F multiplied, that's minus here. F, what is your f? X to the power 4 plus x squared multiplied by 1 minus 2x prime. So there is no room here. 1 minus 2x prime is, so what I should do, just I have to do it here separate. So you have x to the power 4 plus x squared divided by 1 minus 2x, the whole thing prime. So here is the rule that I'm talking about. 1 minus 2x prime squared, 1 minus 2x, and the derivative of x4 plus x squared prime. So that is your f. That is our g. Alright, so g squared, g, that is g f prime minus f, which is 1 minus 2x, and then f prime. So that is your f g prime. F g prime. So what is your g prime? So that is your g prime. What is your f? X to the power 4 plus x squared. You have a prime here, you have a prime here. I'm just apply the rule. G squared. Take whatever you have down here, square, and then g f prime minus f g prime. So if you simplify this, what do you have? You will have 1 minus 2x squared, and then what is? I just try to take the derivative. 1 minus 2x, x to the power 4. What is the derivative of x to the power 4? You have 4x cubed. What is the derivative of x squared? Just 2x. Minus, I put minus here. What is the derivative of 1? What is 1? Constant. What is the derivative of any constant? Yes, it's 0. Minus, what is the derivative of minus 2x? You have just minus 2. Minus 2x, negative 2. If I have here, what is the derivative of negative 2x? You take negative 2 out, and then you have x prime. What is x prime? X prime is 1. X prime is 1, right? I'm just recall this one here. If you know the stuff here, it will be easier and you help me here. If you don't know, then you'll see it's difficult. -2, it's a constant. I grab it outside. You have -2 multiplied by x prime. The x to the power 1 prime, that is will be 1. X to the power 1 minus 1. So that is your n. I put n here, and then I reduce n by 1. What did you get? You get 1 x to the power 0, which is just 1. And here you have, where we have 1 here. What is the derivative of 1? The derivative of 1, it's a 0. It's a constant. The derivative of any constant is 0, right? So multiply by x to the power 4 plus x squared. You take the derivative here as it is, just go up here and then replace it here. So the final derivative, I need to get y prime here. The final derivative should be y prime, n, which is 10, and the bracket, just copy the bracket up, x to the power 4 plus x squared, 1 minus 2x to the power 9, and then take the derivative from here as it is. No simplify, just copy. Exactly the same here. So you have 1 minus 2x multiply by 4x cubed plus 2x, close the bracket, minus -2, right? X to the power 4 plus x squared. I'm just copy the whole thing up. I put it here. That is our y prime. Okay, so that is our power rule, guys. Now I'm going to give you something called a chain rule. What is a chain rule? What is a chain rules, right? So here I give you something called composite or composition of the functions. What is composition of the function or composite of the functions? So I mentioned in the example in the class or last time, you have f is a function in g, and g is a function in x. Your f is a function in g, and g is a function in x. What is the question always they ask? They ask you to find df by dx. What is your f? The derivative of your f with respect to x. What is the derivative of your f with respect to x? So in order to get the derivative of f with respect to x, I have to do here is the following here. I have to just go from here to there. I cannot go from here to there. I have to go. What is the derivative of f? I have to go to g first. It's like bridge, and from g to x. So look what you have. It's like a chain here. I have to take the derivative of f with respect to g, and then here is my handy there at g. Then you have to multiply the derivative of g with respect to x. So the derivative of f with respect to x is nothing but the derivative of f with respect to g first, and then you multiply by the derivative of g with respect to x. It's like here, dg here cancel with dg. What did you get? You get df by dx. And look, f is a function in g, so it's easy to take the derivative of f with respect to g. Your g is a function in x, so it's easy to take the derivative of g with respect to x. And then if I multiply those together, then you are able to take the derivative of df by dx, and that is the reason we call it a chain rule. A chain rule here because like a chain, I have to go to g first and from g to x. So look what you have. It looks like a chain here, right? So how to do this one here? So I'm just I give you some example here so that you will have a feeling about it. So a simple example, and then I can solve some problems. So what happened here if you have your f equal u cube, right? And here u equal x cube minus x to the power, u here is x to the power x cube minus x, all right? So that is given here. So equation 1, and that is equation 2. What is the question here? The question here is to find df by dx. How you get df by dx? By chain rule. So the question here is by chain rule. They are very specific, by chain rules. So which means you cannot use other methods. So people here is what they do, they say, okay, f is a function in what? Oh, u cube, right? Let me apply chain rule, and then I can talk about other method. You can use it to solve the problem. So here f equal u cube. So f is a function in what? F here is a function in u. F here is a function in u. So if I write here f is a function in u, right? So f is a function. If I look to the right hand side, f is a function in u. If I look to u is a function in what? In x. U is a function in x. What is the question? Find df by dx. So df by dx, I have to go from here to there, but I cannot go from f to x. I have to go first to u and from u to x. Right? That's called the chain here, the chain. So df by dx is nothing but df by du. I have to take the derivative with respect to u here, and then multiply by the derivative of u with respect to x. That is called the chain rule. And look what you have. F is a function in u because the right hand side in term of u. So here it's easy to take the derivative of f with respect to u. So if I call this equation 1, the derivative of f with respect to u, that is your n, which is 3. So 3 n minus 1, which is 3 minus 1. So what did you get? You get 3 u square. I give this equation, say number 3, just a number. Just give it a number. Now, what is u? The equation number 2. Equation number 2, u is a function in x. Then it's easy if u here equal u x cube minus x minus x. Then it's easy to take the derivative of u with respect to x. Why it's easy? Because u is a function in x. U here is a function in x. Just normal derivative. So what is the derivative with respect to x for x cube minus x? Then I have to, what do you have in the middle? Minus. If you have in the middle minus means you take the derivative term by term. So you have x cube, the derivative with respect to x cube minus the derivative with respect to x for x. Here x cube, here your n is what? 3. So this one it will be 3x square. 3, I put 3 in front and I reduce 1, n minus 1, which is 2. And here what is that? It's 1. What is the derivative of x with respect to x? Just 1. Why? I can put 1 in front and then I can reduce 1 minus 1. X to the power n minus 1, which is x to the power 0, which is 1. So what did you get? You get 3x squared minus 1. Because x to the power 0 is 1. And then what is this equation? Just give a number. It's 4. So now our chain rule df by dx is nothing but is df by du multiplied by du by dx. So df by du, that is come from equation 3 here. Look what you have here. df by du, 3u square. So I have to copy down here 3u square. So this one 3u square. Right, that is come equation 3. Equation number 4, right? So I have to get equation number 4. That is equation number 4 here, which is du by dx. Du by dx. So I just copy that 3x squared minus 1. So here df by dx means your f should be function in x. When I write y equal f of x like this, look what you have. F is a function in what? X. So when I took the derivative of f with respect to x, means your f is a function in x. So here df by dx, I have to write everything in terms of x. So which means here you have u. What is u, guys? What is u? U here is x cube minus x. That's come from equation 2 here. X cube minus x. Then I go back here. Here that is already, this term is x. So it's okay. I'm not worried about it. Here this term is x cube minus x. That is my u here. That is our u. Square. So x cube minus x. I will replace it. I use equation 2. I use equation 2. Look what you have, equation 2. U equal x cube minus x. So I go back here. I replace u by x cube minus x. Multiply by 3x squared minus x. So now that is the derivative of f with respect to x by chain rule. So here, let me summarize what I did. F is a function in u. So it's easy to take the derivative of f with respect to u. Here, u is a function in x. It's easy to take the derivative of u with respect to x and then multiply those together. Then that is give you the derivative of f with respect to x, and that is called a chain rule. Very simple. All right. So now if I solve one of the other problem here, look what you have. For example, here maybe I solve one of this. I solved already this one. Maybe I solve g here using a chain rule. All right. So what do you have? You have y equal. Maybe I copy this so that I can go up. Right. So I'm just take this one here out. Right. copy, and then I go down here so that I can use a chain rule, right? It's only sometimes we are very specific, or sometimes I tell you just go ahead and take the derivative. So here, how, if I ask you find dy by dx, some people, what they do, they go ahead and they take the derivative, just Bauer rules, because it's a bracket to the power n, a bracket to the power n, use Bauer rule. But some people, they say, well, I try to make it easy for myself. How? I'm going to look what you have, whatever inside the bracket, take whatever inside the bracket, call it u. So what do you have? You have uy equal u to the power what? 4, where u, that is whatever inside the bracket. What is that? 3x minus 1 over 2x squared. So here, again, take whatever inside the bracket, whatever inside the bracket. So just let me write it. Whatever inside the bracket, take it as u. Whatever inside the bracket, take it as u, or f, that is our rules. I take it as u. Then what is the equation becomes? It will be y, whatever inside the bracket as u, it will be u to the power 4, u to the power 4. So now I call this equation 1 and 2. Now I need to get dy by dx. So y now become function in what? In u. Y function in u. U is a function in what? Function in x. So it's easy to take the derivative of y, equation 1, dy by du is very easy to take, which is 4 u to the power 3. 4, that is your n, I put it in front, n minus 1, 4 minus 1, which is 3. I call this equation 3, right? So now, if I look to equation 2, what do you have? U is a function in x. U is a function in x. If u is a function in x, then it's easy to take the derivative of u with respect to x. So now I have to take the derivative of u with respect to x. So here you have 3x, excuse me, minus 1 over 2x squared. So this one here, I can't grab this. I need to take the derivative of this. So how to simplify this? What do you have in the middle? Minus. Then I have to take the derivative of the first term, which is 3x, minus the derivative of the second term, which is 1 over 2x squared. Right? So now, what is the derivative of 3? 3 here, it's a constant. I can grab it outside. So what do you have? You have x inside. And here, 1 over 2x squared, I need to simplify. How to simplify this? Let me, you can use, if you want, you can use apply quotient rule, because 1 over 2x squared, 1 divided by 2x squared, or some people, they like to avoid quotient rule, so you say 1 over 2x squared. This one is nothing but is 1 over 2 multiplied by 1 over x squared. Is that correct? It's the same? Yes. 1 over 2, that's a constant. I leave it as it is. 1 over 2, I leave it as a constant. Only I'm going to take this term, I put circle here. This term, I took it up. When I take x squared up, what is the exponent 2? It will be negative 2. When I take the exponent 2 up, become negative 2. So this term, now it will be easy, negative, this term, I could write it as 1 over 2 x to the power negative 2. Right? I leave always, I don't touch the constant. I leave the constant as it is. Only I take your unknown or your variable, which is x, your variable x, take it up, take the opposite sign. Now 1 over 2, it's a constant. I can grab it. So now what is the derivative of x with respect to x? Yes, I'm hearing 1. That's correct, because x to the power what? 1. So what you have, your n here is 1. So you have 1, x to the power 1 minus 1. And here, minus 1 over 2 up. I take 1 over 2 out. So what you have, your n, negative 2. So what is the derivative? Negative 2, that is your n. And here, n minus 1. N minus 1. That is my derivative. So you simplify this. You get 1 minus 1 is 1? 0. X to the power 0 is 1. And here, what you have to be careful. You have negative sign here. You have negative sign here. You have negative sign and negative sign. So when I multiply negative sign with negative sign, what did you get? You get positive. You get positive, right? Positive. And then, what do you have? You have 2. 2 here cancel with 2 here. So what do you have left? X to the power negative 3. X to the power negative 2 is negative 1, you get negative 3. Negative times negative here, you get positive. 2 here cancel with 2, you get 1. And that is du by dx. And that is, this equation is, we call it number what? Number 4. Number 4. So again, back, if I go back here, the question is dy by dx. What is dy by dx? It will be dy by du multiplied by du by dx. dy by du multiplied by du. That's called the chain rule. dy by du, that is equation 3. Du by dx, that is equation 4. That is give you the derivative, which is dy by dx, because like du here cancel with du, you get dy by dx, but that's called the chain rule because your y is a function only in u and u is a function only in x. So now if I go back here, I just try to replace dy by dx. I'm just copy, it will be dy by du and du by dx. So that is equation 3 multiplied by equation 4. So equation 3 here is 1. Just go up. Here is equation 3. 4u cube. 4u cube. So you have 4u cube. And what is du by dx? Equation 4 here. Sorry, that is equation, that's du. Equation 4, which is 3 plus x to the power negative 3. You can leave it like this, is okay. If you want, you can replace u by the function. U here is a like bridge. Remember I said u as a bridge, so it's only they are not going to see u at the end. What is u? 3x minus 1 over 2x squared. That's equation 2. U, whatever inside the bracket, that's u. So here I could write it as 4. What is inside the bracket? Just copy from up. 3x minus 1 over 2x squared. So 3x minus 1 over 2x squared to the power what? To the power 3. So that is u here, that is u come from equation 2 and multiply by 3 plus x minus cube. That is if they ask us to use a chain rule. If I ask you to find the derivative, you have the freedom to use Bauer rule, or you have to use what's called the chain rule. All right, either or the same, you will get at the end the same solution. But sometimes we don't have what's called the choice, because the question very specific. We have to use what's called Bauer rules or a chain rule. Okay guys, so now I have to give you some application related to the chain rule. I'm just going up here some applications. So let me solve this one here. Maybe I took those two here. Okay, started to solve number 2. I solved that in class here, but it's okay to. So I'm going to solve this problem down here. It's kind of application to chain rule, which is good to solve these ones. Okay, so I'm just solving maybe number 10, and then I can solve a couple of problems here about the chain rule, which is not bad. Here we're good to solve. All right, so now guys, here it's application. Now how to solve the application. You read the question before you read the problems. So what is the question here? I look for question mark. I look for at the end here, or use. Look what here is the question before I read the problem. Use the chain rule to find dp by dn when n equal 10, and try to explain the result. What is the result means? What the result means? All right. So now I have to figure out what is db by dn when n equal 10. So now I have to read the problems, but I have to understand what is n. N equal what? What is p? What is the known? What is given here? So you have a company has annual profit. So your p here is, that is the annual profit, right? So that is a company, you have annual profit. They give you the equation already, which is b of q equal to minus 100,000, right, plus 5,000, q minus 0.2 minus 0.25 q square. I call this equation 1. What is your q, guys? What is your q? Q here is given. Q is the number of laptop, right? So number of laptop. All right, so I have to write this number of laptops. Just copy from there so that you understand. The number of laptops, it sells per year. So it sells per year. The time here is year. The number of laptops company, it can be manufactured per year, depend on n. What is n? What you have, your n here is number. Your n here is number of what? Of engineer. Number of electrical engineer. So you have to write number of engineer, right? So that is information given. So now what is q? They give you q, that is the number of laptops. The relation between number of engineer, which is 30n, plus 0.01, right? 0.01 here. I'm just copy this, n square. So I call this equation 2. q here is the number of laptop or number of computer. What is my n? Your n here is number of engineer. So number of engineer here, it's a relation between the number of engineer and the number of the product or number of item, which is laptops. So equation 1, as you can see, your annual profit P is a function in Q, and Q is a function in N. So let me write it here so that you can see what is given to you here. So let me write P is a function in Q, right? Here is, look what you have, the right hand side here is Q. So everything in terms of Q, and here written even P of Q means B is a function in Q. Q is a function in N. If I look to the right hand side here, everything is written in N. So your Q is a function in N. What is the question here? The question here, look what you have. Here is your question. DB, what is the derivative of your annual profit with respect to N? The derivative of your annual profit, or sometimes we ask when the annual profit is going to change. When you see word change or how fast or measure, because the derivative here is kind of measure the change of your function, which is P, your annual profit, how is going to change, means you have to take the derivative with respect to here the number of engineer. That is the questions when n equal 10. So here the question they ask you, what is the derivative of B with respect to N? But I cannot go from P to N. I have to go first to Q, and from Q to N. I have to go to Q first and from Q to N. And that is called here a chain rule, because that is our chain rule here, because I go to the bridge which is Q and from Q to N. So here the chain rule dP by dN is dP by dQ multiplied by dQ by dN, right? So here dB by dQ, that is, I call this always equation number 3, and this one equation number 4, right? So now it's very easy also equation number 1, because P is a function in Q. It's very easy to take the derivative with respect to Q. It's very easy to take the derivative with respect to Q. So right, so you can tell me here, guys, what is the derivative? Equation 1, from equation 1, what is the derivative of P with respect to Q? In order to take the derivative of this, here is the derivative with respect to Q. It will be minus 100,000, right, plus 5,000, Q minus 0.25 Q square, right? I'm taking the derivative of this. What is good news? You have in the middle here plus, you have minus. If you have in the middle plus or minus, means you take the derivative term by term. The derivative of minus 100,000, that is the first term, plus the derivative of the second term, which is 5,000 Q, minus the derivative of 0.25 Q square. So what is the derivative of any constant? It will be 0. Take 5,000 out, and what is the derivative of Q with respect to Q? It will be, if I take 5,000 out, you have the derivative of Q with respect to Q. Take 0.25, that's a constant, 0.25 out. So what is the half? You have the derivative of Q square, the derivative of Q square. So now what is the derivative of Q? Here Q to the power 1. So you have 5,000, and here 1, and Q, that is your N, and then 1 minus 1, which is N minus 1. What is Q to the power 0? Q to the power 0 is 1. Here 0.25, and here what is your N? 2, and what is your N here? It will be N minus 1, which is 2 minus 1. So what did you get? You get 5,000, and Q to the power 0, Q to the power 0 is 1, 0.25, and here you have 2. So 2 multiplied by 0.25, what did you get? You get 0.5, right, multiplied by Q. I call this equation number 3, right? So that is your equation 3. Now if I go back here, I need to get, as I told you, when I look to equation 1, P is a function in Q, so it's very easy to take the derivative with respect to Q. Equation 2, Q is a function in N. Q is a function in N, then it's easy to take the derivative with respect to N, right? So here I have to take the equation 2 here. I'm just to try to see the equation 2. I'm going to take the derivative of Q with respect to N. So what is your, I'm just copy N, copy for Q from there. You have 30N plus 0.01 N square. So you have 30N plus 0.01 n square. I close the bracket. So you have, I just review 30n.01 n square. What you have in the middle plus, then I have to take the derivative term by term, which is 30n plus the derivative of n 0.01 n square. So that's a constant. I can grab it outside. So what do you have left? N to the power 1. And here I can take 0.01 outside. Alright, so what do you have left? N square. What is the derivative n to the power 1? Is 1. So what did you get? You get 30 here. The derivative n to the power 1 is just 1. Right? And then you have 0.01. What is the derivative n square? You get 2n. If I simplify this, 30.01 multiply by 2, multiply this number, multiply by 2, you get 0.02, multiply by n. I call this equation 4, right? 4 here. And what is the question? The question here is I need to find dB by dn. But what is dP by dn? It will be dB by dq and multiply by dq by dn. That is our chain rule. Remember, I wrote it up here. Look what you have here, this one. That is equation 3 multiplied by equation 4. Then you are almost done, because they tell you here. So equation 3 multiplied by equation 4, right? So where is equation number 3 here? Equation 3 here, that is the one. I'm just copy that. 5,000 minus 0.5 q. 5,000, right? 5,000 minus 0.5 q. That is equation 3 here. Equation 4, just a copy from there, 30 plus 0.02 multiplied by n, that is equation 4. But what is the question? We are done almost, because they ask you what is the derivative when n equal 10? When n equal 10. So here, it's easy to replace n by 10, but here you have q, not n. Is there any relation between q and n? Yes, that is equation 2. Equation 2, the relation between q and n. So here in this equation 2, what happened if I replace n by 10? When n equal 10, what is your q, guys? What is your q? Q here is just replace n by 10. So you have 30 multiplied by 10, right? Plus 0.01 n square. What is n square? You have 10 square, which is 100. 100 multiplied by 0.01, you use technology, you get 1. Multiply, so you get 301. When I use technology, you get 301. So now when n equal 10, in equation 2, you get q equal 301. When n equal 10, your q equal 301. That is from equation 2. So when I come down here, just replace q. Just when n equal 10, what is q? It will be 301. Just go ahead and replace q by 301. So you have 5,000 minus 0.5 multiplied by 301. Close the bracket. Just I replace q by 301. I replace n by 1 by 10. I replace n by 10. I close the bracket. Use technology here, and then the technology is going to give you the number. So let me tell you the number here after I use technology here to get the number. So here is the number I got. Here is just you write it. So it will be 4645.90, right? So now I need to get the unit. What is the unit of this? The number here. What is this number? Unit of the number. Look what you have. The derivative. The derivative dP by dn. What is P, guys? What is your P? That is your annual profit. Your P here is annual profit. What is your annual profit here? Annual profit means it's dollars, money. So that is will be dollars. Bear engineer, right? Because what is your N? That is the number of engineer, right? A number of engineer. So that is your annual profit, which is in dollars, bear engineer. So that is your, but what this one here means, right? What this one here means at, just let me write it, at here, employment level, just try to see here, employment level of 10 engineer, right? So you have 10 engineer. The company here, right, will increase, right? Increase the profit, or maybe increase, just write increase here, right? Increase here. It's a profit, is going to increase its profit by at rate here. I'm just write the rate here. I'm just explain this one here. All right, at rate of approximately almost, right, approximately here. I'm just writing approximately this amount, which is 146,045 per additional engineer. Right, just write here handwriting additional engineer. So for if you try to increase one engineer, then you are going to make profit for 146,455. So this amount, it will be increased. So this one here similar to when you have y equal, I'm just as a remark here so that we will try to understand why this number here, why, how did I get this conclusion or explanation, how did I explain this? If you recall here, guys, y equal, what is y equal here? So if you recall, first I again give you two examples here. Y equal to 2x plus 1. What is that? That is your slope, right? Y equal mx plus little b. That is your slope. Your m here is slope, right? And your slope here, when x increase by 1 unit, your x increase how many unit? 1 unit. 1 unit by 1. What happened your y? Then your y is going to increase by how many unit? Your y increase by 2 unit. That is your slope. Whatever your slope here increase, it's your slope is positive 2, then your y increase by 2 unit, right? You can see that. Even it's easy to see by me just make a table here. If you have xy, take x1 2 3 like this, replace here x by 1. What did you get? You get 3. 2 plus 1, you get 3. When I replace x by 2, 2 multiplied by 2, you get 4 plus 1, you get 5. If I replace x by 3 here, you get 2 multiplied by 3, 6 plus 1, 7. As you can see here, what is your x? X increased by 1. X increased by 1. What is your y? Your y increased by 2. From 3 to 5, 2. So how did I figure out 2? That is from the slope here. Likewise, if you have the slope is negative 1, negative. If you have negative, then when x increased by 1 unit, then what happened for your y? Increased by 1 unit. Then your y is going to decrease. Your y is going to decrease, going down by how many unit? By 2 unit. 2 unit, because your slope here is negative, then is going to tell you your y is it will be kind of decreased by 2 unit. Okay, guys, so that is similar to, but what is the relation between slope and derivative? That is what you have. You remember when I said the slope is what? Your derivative at when x equal a. Your derivative at x equal a, that is your slope. Slope of what? The slope of your f. That is the slope of your f of x, especially if your f non-linear. So that is for linear case, it's very easy to see. But if you have your f non-linear, then it turns out the slope is nothing but your derivative when x equal a, a specific number. And that is the slope of your f of x, where f here could be non-linear. Or that is also the slope of the tangent line, Remember that? The slope of your tangent line. The line touch the graph of your f of x at x equal a. That is your slope too. Right? So here, the same. Look what you have. What is your slope here? dB by dn. That is your derivative at n equal 10. So like slope at n equal 10. So this one, it's like b prime at 10. b prime at 10. This one, b prime at 10, means your slope at 10. When n here, instead of x, you have n equal 10. And the slope here, what did you get? You get positive number. So this slope means your p, what is your p here? Your annual profit is going to increase by slope here, which is the number here is $146,000. When x increase, what is your x? N. What is your n? Number of engineer increase by 1 unit. So for additional 1 engineer extra, then the profit is going to increase by 146. If you have this number, negative number, then your profit is going to decrease, or you are going to lose this certain amount of money, because if your slope or your derivative is negative, then it will be decrease because the slope is negative. If you have positive, your derivative positive like this in our case, then it will be increase. Which one is increase? Your P. What is your P? Your annual profit is going to increase. All right, so that is, I hope it will be clear here. Likewise, I give you maybe another example here, and then the rest here I can provide the solution. You can check it. So if I solve this one here, again, it's a chain rule, application of the chain rule. So now, before you read the question or the story, just read the questions. Here a question mark, so I go backward. Just what change? Whenever you see word change here, or how fast, all these kind of question, they means a derivative. Means derivative, guys. It means a derivative, especially if you have, unless you say the average rate of change, but that's not the question. What change in spending level here of the government expect if the inflation rate rise from 7 to 8, when increase by from 7 to 8 like 1 unit. So inflation rate. So here they ask about the derivative. What is the derivative? They ask about derivative, means the derivative of spending level with respect to inflation rate. So now I have to read the story, but I keep in mind spending of the government, that's the derivative of that with respect to inflation rate. So now I have to read what is given here. Go ahead and read the rate of government spending level. So that is kind of a spending level of certain country, certain government. What you have, billions. So remember this equation or scale by billion of dollars. So the number that you have is written in billion of dollars. It's not just a dollars. So what is given here, G of U is 193 plus U 6 over 5, right? So you're try to understand here related to unemployment as G of U. G here, it's very important to understand what is given to you so that you can explain what is the number mean. So here G, guys, G, what is your G? Level of government spend. Level of government, the government spend, right? You just copy from here, level of the government spending. So that is your G, right? What is U? G here is a function U. What is your U? U here is percentage of unemployment rate. Unemployment rate. All right, so I'm just writing. Call this equation. Your G is a function in U. U unemployment rate. G, that is the level of spending money of the government, and this money must be in billion of dollars. That is what is given. So now I go for the second, keep reading. Reading here the percentage of unemployment rate. It turned out they give you a relation between unemployment and inflation rate, which is U of, just let me write it here. What you have here, guys, it will be kind of easy, but just let me explain equation 2. U is a function in I. That is here, this equation U, a function in I. What is written 80? And what you have, I plus 10 to the power what? Negative 1. So that is equation 2. I, what is your I? Just explain I here. That is our inflation. So your I, I'm just writing here so that everything will be clear. I is inflation rate. All right, so now return back to the questions. That is equation 1, equation 2. So if you look to equation 1, G is a function in U. Just let me write it. G here is a function in U. U from equation 2 is a function in 1, or U in equation 2 function in I. What is the question here? With the question here, they tell you what it change. What it change mean the derivative in a spending level, that is your G of the government, G, with respect to inflation rate, which is I. So they ask about the derivative of G with respect to I, right? The derivative of G with respect to I. But I cannot go from G to I straight. I have to go to U first, and from U to I, right? So that is our chain rule, because I cannot go from G to I and then U to I. So now what I have here is just what I have here, dg by di, the derivative is I, is nothing but dg by du, and multiply by du by di, right? So I have to go to the derivative with respect to u and then multiply by the derivative of u with respect to I. I call this equation 3, I call this equation 4. So now if I look to equation 1, it's easy to take the derivative of g with respect to u, right? Equation 2 also it's easy. Look what you have, guys, here. Maybe I change the colors so that you will see the equation 3. So here, what is the derivative of g with respect to u? What is the derivative? Is easy to write it here. What is the derivative of g with respect to u? That's a constant, right? What is the derivative of any constant? 0. Now, what is the derivative of u to the power 6 over 5? 6 over 5, that's n, 6 over 5. And then 6 over 5, right? And then what do you have? 6 over 5. What is your u, guys? U, it will be 6 over 5 minus 1. 6 over 5 minus 1. What is 6 over 5 minus 1? You can use technology if you want. You can have 6 over 5. 6 over 5, u to the power 1 over 5. 1 over 5, right? Because 6 over 5, if you want, you can write it here. 6 over 5 minus 1. You can write 1 as 6 over 5. You can write 1 as 5 over 5. So 6 minus 5, you get 1 over 5. So that is 1 over 5. That's the reason. I call this equation number 3, guys, in red. Now I have to look for equation number, u is a function in I. So it's easy to take the derivative of u with respect to I. How to take the derivative with respect to I? Here, I, 80. I here plus 10 to the power negative 1, right? 10 to the power I plus 10 to the power negative 1. You have a bracket to the power negative 1, which means Bauer rules. So now I have to get the equation du by di. 80, that's a constant. I can grab it outside of my derivative. So what do you have left? I here, that is your I. And here you have I plus 10 to the power negative 1, that is your n. It's a bracket to the power n. Bauer rules. What is your derivative of my Bauer rules here? You will have 80. So 80, that's a constant. Now, Bauer rule, how to get the derivative of Bauer rules? N in front. And here is your bracket, which is I plus 10, n minus 1, multiplied by the derivative, whatever inside the bracket. The derivative, whatever inside the bracket. So negative 1 multiplied by 80, you get negative 80. I plus 10 to the power 1, negative 2. Negative 1 with negative 1, you get negative 2. Now, what is the derivative of I plus 10? What is the derivative of 10? 0. Very good. Why? Because it's a constant. And then, what is the derivative of I with respect to I? That's a prime. What is the derivative of I with respect to I? Is 1. The derivative of I with respect to I is 1, right? So here, try to make it clear for some of you here. The derivative, I need to get the derivative of I plus 10. Right, this part here, I'm talking about this part. So I here, it will be di by di plus d by di 10. 10 here is 0 because it's a constant. Here I by di is nothing but is 1. So I plus 10 is 1. So that is, I call this equation number 4. So now here is your, I go back to change the colors, just a normal. So d here is the formula I'm going to use. dg by di, equation 3, you just take from up here, equation 3, 6 over 5, u to the power 1 over 5. So let me write it, 6 over 5, u to the power 1 over 5, that is equation 3. Equation number 4, just copy from here, which is negative 80, I plus 10 to the power 1, negative 2. So that is equation number 4 here. Equation number 4, that's our chain rule. Did you finish? Yes, almost finished, because that is applying now chain rule. So what is the question? They tell you what a change in spending can the government expect if the inflation rate from 7% to 8%. So when your I equals 7, so I have to take the derivative here when I equals 7. 7% means 7. So now look what you have, guys. When I here, you have I equals 7, I could replace I by 7, but here also you have u. So when I equals 7, what is your u? U equal what? So that is come from equation 2. Look what you have, equation 2. The relation between I and and u. If I replace I by 7, then you are able to get u, right? So if I do that here, just replace, if I do it in this part here, u, it will be 80, right? I, what is I? 7 plus 10 to the power 1, negative 1. So which means 80 multiplied by 17 to the power 1, negative 1. If I replace I by 7, so 7 plus 10, you get 17 to the power negative 1. 17 to the power negative 1, you have 80 here. So which is, your u is 80 divided by 17. 18 to the power negative 1 is 1 over 17. 1 over 17. 17 to the power negative 1, I can write it down as 1 over 17. So you get 80 over 17. So I go back here. So when I equals 7, so what is your u? Your u here is 80 over 17. So I go back here and just replace here, guys. Just go ahead and replace u I by 7 and u by 80. Then you are able to get DG, the change of the spending government with respect to inflation rate. So what do you have? You have 6 over 5. U, what is u? 80 over 17 to the power 1, to the power 1 over 5, right? And here, what do you have? Negative 80. Here, negative 80 I. What is your I? 7 plus 10 to the power what? Negative 2. Close the bracket. So I just use technology here. So what do you have? Negative 80 here, 17 to the power negative 2. So let me give you the number here, guys. What I got is negative 0.0453. All right, negative 0. When I use technology, I simplify this. Now let me write the unit. What is the unit here? What I should write? What is DG? What is the unit of G? What is the unit of G? The unit of G here is what? That is spending level of the government. Spending level of the government. That is, if you look to the problem in billion of dollars, here billion of dollars. So this one billion of dollars, that is your G. With respect to I, what is your I? Inflation rate. So that is, it will be, if I write it here, it will be billions. I should write billion of dollars, right? Bear, inflation, bear, or divided by I. G, billion of dollars divided by I. What is I? That is a percentage of inflation rate. Percentage of inflation rate. So that is the unit of this one. So what you really care, explain this number. What this number means if your inflation rate, if the inflation rate, right, raises from 7%, increased by 1 unit, 7% to 8%, then the spending, there is a decrease here, right? A decrease of in government spending, right? In government spending, right? Spending, just government spending. I'm just writing here the government spending here. I'm just finishing here. I know I feel tired. Government spending, right? Approximately here. I'm just writing, right, by how many? 45.3 millions. It's $1 million, because this number here you are going to multiply by billion of dollars, billions. So if you have 0.453 multiplied by billions, you get, the government is going to reduce for $453 million, right? Or just write this number here, just copy this number. Minus means there is a decrease. If you have positive, it will be increase. But if you have negative, decrease, going down. All right, guys. So here, that is the way that it's called the chain rule. So again, here is, it's very, very simple here. If you look to the equation is given, two equation. G is a function in U, which is easy to get the function with respect, to take the derivative with respect to U. Here, U is a function in I, which is easy to take the derivative of U with respect to I. And then multiply those derivative. That's our chain rule. Then you are able to answer the question. Here, when I equals 7, what will happen for your derivative? If it's positive, then increase. If it's negative, then it will decrease, going down. All right, guys. So that is very much what I have done. It's called a chain rule. All right, so I will stop here. Thank you.